Hello and welcome to this network education video. My name is Russell DeLong and this is the EPS Attach Procedure. While the 3GPP defines a number of different mobility procedures for the Evolve packet system, the EPS Attach Procedure is the most fundamental and almost certainly the most valuable, especially from a troubleshooting perspective, to know and understand. Realistically, if there's a problem with the network and subscribers are failing to register, subscribers are failing to establish an IP data session, the EPS Attach Procedure really is the place to dig into to try to understand what may be going wrong. And it all starts with an attach request. So the user equipment, your cell phone, sends an attach request to the eNodeB, to the cell site. I want to connect to the network. Basically the message here. The user equipment includes its identifier, which for the first time it connects will be his IMSI, the SIM card's International Mobile Subscriber Identifier, unique number for that SIM card. In the next attach, it would most likely send a temporary identifier called the GUTI, which is an identifier that the MME has given it to use over the network rather than use his IMSI. The reason is because encryption is not set up at this point. And the white papers, the 3GPP wanted to reduce the number of times that the IMSI itself was being sent over clear text, just because it is a permanent identifier for your specific SIM card. So in this attach request, the subscriber will send supported capabilities. So he will say, I support this kind of data rate. This is the bandwidth that I support over the radio. This is the quality of service that I support. He will also indicate whether or not he wants to request a specific data service or if this is just a default attach. Default attach procedure, the network decides what external PDN, what external data network to connect you to, based on your provisioning info or your policy info. The device can specifically request what destination network he is trying to reach, but he won't do it in the attach request. What he'll do is he'll set a flag that says he wants to request something specific. But again, because encryption is not set up at this point, basically the desire was to reduce the amount of information that's available in this clear text message. So all he does is say that he wants to request something. He won't say what at this point. The eNodeB determines which MME to send the request to. Now the eNodeB can do this in a couple ways. Potentially you can have it hard-coded to say this eNodeB is served by this MME. So just always send requests to this MME or one of these two MMEs. You could do like a round-robin load balancing where the first request comes to the first MME, the second request gets forwarded to the second MME. The eNodeB could also potentially use DNS for this, where the eNodeB will query a DNS server to get a name of an MME to serve the subscriber or multiple names to dynamically learn what MMEs are available to him for attach procedures. And this request is going to be forwarded to the selected MME. So auth info, authentication info request and response. So once the MME gets that attach request, he's going to authenticate the subscriber. It's mutual authentication. So he's going to query the HSS for subscriber info, for his key information. So I don't want to get too much into the actual encryption process, but basically the user equipment has a K key. The SIM card actually has that K key, an encryption key, that the HSS has as well. It's a pre-shared key concept. This key is never transmitted over the air, and it's never transmitted towards the MME even. Rather, the HSS will take a random number, use that random number in the K key to generate what's called the KASME key, which he will send to the MME. It gets a little bit complicated. There's actually several keys that end up being created and negotiated here. So the MME will send eNodeB, integrity key, cipher key, and all this good stuff. Don't worry too much about that, but basically, the user equipment has a K key, this one key that is checked against the HSS, and it is a mutual authentication between them, and encryption is set up at this point as well. So the EPS Attach Procedure update location request. So assuming that authentication is successful, the MME will declare itself to be, or at least request that it be, the MME that is serving the subscriber. So the subscriber is now located, that's the location name, he is located at this MME. The MME will declare that to the HSS. So the HSS will update the location register and say, okay, I've got an entry here for this subscriber. His last registered MME is now going to be this MME. If there was an old MME, it would trigger the HSS to send a cancel location to disconnect the old MME, just to make sure that everyone's on the same page in terms of where the subscriber really is right now. And he will also send a response to the MME, update location answer. Update location answer, it's a little bit of a misnomer. It makes sense in the context of the protocol called diameter, where it's all request and answer messaging. That's kind of the convention, but really this could be considered what's called insert subscriber data. If it was sent on its own, it actually would be called that, insert subscriber data, where the HSS is telling the MME what service. He's not only acknowledging the update location, but he's also saying this is the services that this subscriber has. So this subscriber rather has access to this data network with these QoS settings and this data network with these QoS settings. He gives all that information to the MME at this point. So now that the MME knows that the subscriber is authenticated, he knows he's a legitimate subscriber and he is trying to connect, he will consider what APN the subscriber requested. I skipped over it here, but after this authentication, an optional procedure, and I'm trying to include only the mandatory, but there's an optional procedure called Cipher Options Request and Response, where the MME will say, okay, now that encryption's set up, what did you want to ask me about? And then the UE will say, well, here's the specific IP service I want it to connect to. So once all those exchanges have happened, the MME knows what the subscriber's provisioned for. Got that from the HSS. He knows his key information. He has authenticated the user. The user is trying to connect to a specific network, or he's trying to connect to a default network, which will be given to him by the HSS. So the MME will then decide what service the user can or should be connected to based on what he's requested. He will then figure out what P gateway can serve that external network. And he'll figure out what S gateway can serve this eNodeB that the subscriber is connecting on. He will actually use DNS for this. Now, DNS is such a big topic for LTE, I suspect I actually plan to make a dedicated video just for DNS and this concept of gateway selection. What's really going to happen is the MME will ask, there's 4 queries altogether that would happen here. 2 of them are called NAPTR queries, so sort of a service request. The questions he'll ask in sequence are, what PDN gateway can serve this PDN that the subscriber is trying to reach? First question. Second question is, what is the IP address of that PDN gateway? Third question is, what serving gateway can serve this eNodeB, or this radio network that the subscriber is in right now? Really, what serving gateway can serve the tracking area or group of cell sites that the user is in right now? And then finally, what is the IP address of that serving gateway once he's selected one? So this whole topic here is probably going to be its own video because it gets a little bit complicated. And really DNS in general and how it plays into LTE and the EPS call flows. So the MME will finally decide on a serving and PDN gateway pair, and he will forward a create session request to the serving gateway. He will include the APN that he's decided to request for the subscriber, which may or may not be what the subscriber asked for, may or may not be what the HSS requested, but I would be very surprised if any operator would allow the MME to request an APN not provisioned in the HSS as permitted. Sort of defeat the purpose of the HSS in this role, but potentially MME will dictate the APN to request here towards the S gateway and QoS settings that have been selected so far for this bearer. It is a request. Everything that's happened up to this point is not set in stone. The APN that the user is going to get connected to, the quality of service he's going to have, none of that is actually set in stone at this point. This is a request. You'll notice as well that there's no connection between the MME and the P gateway. He's really using the S gateway as a middleman to get to the P gateway. He's really saying, S gateway, I need you to talk to this P gateway. And he includes the IP info of the P gateway that he's decided that this S gateway has to talk to. So create session request will get forwarded to P gateway. Basically, it's the transparent forwarding of whatever the MME sent. Now, tunnel endpoint IDs are starting to get negotiated, and what these are, okay, so you really have 3 legs of this data session that's being built, and 2 of them work on GTP tunnels. These 2. So the way that a specific session is mapped in this common connection between this S gateway and P gateway, it's a combination of IP address and tunnel endpoint ID. So the S gateway will say, here's my IP address, and for this specific session we're setting up, if you want to reference it, reference tunnel endpoint ID 123. That's what he's sending here. So any future messages that you send to me that are relating to tunnel endpoint 123, I will know that it's this session that we're setting up right now. That's kind of the idea. So the PDN gateway gets this request for the session. He'll make note of the tunnel endpoint ID and everything else. He will look at the requested APN and QoS settings that have been requested for this bearer, and he will respond with what it will actually get. He'll at this point issue an IP address for the subscriber. This could be IPv4 or IPv6. So really, he is the IP gateway of the subscriber. It's going to be a series of tunnels up to this point. The user equipment, if he's in network 10.0.0. I don't know, make something simple, 10.0.0.2, if that's his IP address, and it's a /24 network. If that's his IP address, his default gateway is 10.0.0.1. His logical default gateway would be the P gateway. Now in this case, the analogy is actually a little bit closer to point-to-point protocol, so there really isn't a default gateway, he just sends, but that is the concept. His IP reference point is the P gateway. And he will send, sorry, I'm getting a little bit off here, so P gateway will issue an IP address for the subscriber, and he will respond with a create session response to the S gateway. He will issue a tunnel endpoint ID as well on his side, so both sides will know each other's tunnel endpoint IDs to reference this session that's just been being built. He will also dictate the QoS and APN settings from the perspective of the Evolve packet core. So this is whatever is in this create session response. This is important to note. If you're trying to trace what APN is actually getting selected for a subscriber or what his QoS settings should be, for one, it should be available in the MME once it's set up. But really, the definitive answer to all those QoS questions is in the create session response. So, like again, Wireshark trace or something right here. Create session response. That is the QoS, and the S gateway is going to forward it to the MME as well. Create session response, again, whatever's in that response should be unaltered between these two, and that is the QoS for this data session being created. The reason the P gateway is the dictator is because he has other pieces of information available to him. So up to this point, we've only been talking about the bare bones of the Evolve packet core and the bare minimum that is required to have an EPS network at all. There are optional things I mentioned before, so PCRF, Policy Control Rules function. So where the HSS has high-level, sort of all-the-time policies for the subscriber, P gateway could query the Policy Control Rules function, and he could have built-in logic to say, oh, well, at 2 in the afternoon it's busy hour, so don't give him those QoS settings, give him lower QoS, or give him lower data rates, potentially. You could talk to an online charging server, OCS. He's got an interface there called GY, so this would be GX interface and GY if you want to look those up. So OCS would say, oh, the subscriber doesn't have balance, or he's going to have balance for this type of service or not that type of service. So P gateway is really just in a better position to dictate the quality of service for the session because he has all these other hooks into all these other systems and potentially more awareness of the real-time state of the subscriber's services and what the network would, or what the carrier would want to issue the subscriber for this session. Create session response, sorry, go back and change colors here, and create session response back to the MME. The MME, once he gets that create session response, if he's okay with it, in theory he could perform what's called call admission control, CAC, and he could say, well, that QoS is just not good enough, or this session for whatever reason can't exist because of resources. He could potentially reject it, but he can't change it. Whatever was in the create session response is the QoS for the bearer. Incidentally, this, again, if you look at the session being built, these 3 connections, from the perspective of the P gateway, it's already done. This is the last message. That create session response that he sent across like this, that's the last message the P gateway is going to send in this whole call flow. So from his perspective, this S5 interface, this S5 bearer would be the term, it's built, it's done. But of course, attach accept, so the MME has to tell the UE about this, so he'll send attach accept message out like this. It includes the IP information that the PDN gateway issued. pGateway can also give things like, it's really sort of similar to DHCP. He can give the DNS server that the subscriber should use to resolve IP addresses in the destination network he's trying to reach. In the same packet, it sends the initial context setup request to the eNodeB. So he's setting up really the connection to eNodeB as well. He's including tunnel endpoint ID of the serving gateway. So again, this leg has to be built, this second GTP tunnel, which works the same exact way with IP and tunnel endpoint ID information. So in this attach accept, he's really talking to both at the same time. So the same packet, this one, the protocol is S1AP between the MME and the eNodeB. He's sending a message to the eNodeB, and in the same packet, he's sending a separate message to the UE, where the eNodeB will receive the request that he's being asked, and he'll send a response. And at the same time, he'll forward the request being sent to the UE. Initial context setup request is the request to the eNodeB, and then attach accept in the same message is the request to the UE. The MME includes the IP address and tunnel endpoint ID for the serving gateway. That's what he's sending to the eNodeB in that setup request. The eNodeB forwards the attach accept as part of, again, that radio resource control radio message to the UE, and will also include the radio bearer identifier, so the RENTI, or the eRENTI, I believe it's called the evolved RENTI, to the UE to establish the radio bearer. So he's really sending two messages. He's sending the MME's message, and he's sending his own information to the UE as well. It's not just completely transparent forwarding. Attach complete. So the UE, the user will acknowledge that radio resource control message from the eNodeB, creating the radio bearer. So this UU interface. And you'll also hear the term RB, or radio bearer, the connection between the UE and the eNodeB, for this specific data session. The UE sends an attach complete to the MME, and in the attach complete being sent to the MME, the eNodeB also sends the initial context response. Yeah, so the eNodeB will then acknowledge the initial context request message that was being sent by the MME in that last exchange, and that will include the tunnel endpoint ID and IP information of the eNodeB, again for this leg here. So they're really setting up two paths at the same time. They're setting up this radio bearer, and they're setting up this middle connection, this S1 connection between the eNodeB and the S gateway. At this point, with this attach complete, and this with this acceptance of the RRC message, you can say that this path is complete as well. So just to recap, as soon as the pGateway sent that create session request, and S gateway sent this create session response, as soon as those two messages happened, this guy is basically built. This S5 bearer is built. And as soon as the UE to eNodeB connection, as soon as he sends this acceptance to the RRC message saying, okay, good, we have a radio bearer now, this is good, and this is good. The only thing that's left for this end-to-end bearer, this end-to-end tunnel we're building across this network, is the eNodeB to S gateway. Alright here. And the eNodeB, sorry, I'm sort of getting a little bit scrambled, but attach complete. When the UE sends the attach complete, the eNodeB also sends the tunnel information of this last leg that we are building. Modify bearer request. So the MME, once he receives that tunnel information from the eNodeB, he'll send it to the S gateway and say, alright, so here's the IP and tunnel information for the eNodeB. You already sent me yours for your S1 bearer you are building. At this point, when the S gateway gets it, eNodeB and S gateway both know each other's tunnel endpoint ID information, and this bearer is built. So this is the last message. Modify bearer request is the last message in the basic framework of the attach procedure, the EPS attach procedure, where you have all three of these legs built. The user can now send IP data all the way to the PDN gateway, and the PDN gateway will do his packet forwarding towards the external PDN. Done. Simple, right? It might take a few times going over it to just sort of really drive it home. I know there's a lot happening here. And 3 different sessions being built in this same call flow, and sometimes in bits and pieces in the same message. So let's see here. Acknowledgement of this message completes the bearer. So quick summary. I just wanted to And just because I know there's a lot of this happening, at least when I was first going through this, I had to read through a number of different times to really get everything in one go. So the UE asks to connect to the network. It says, hey, I want to connect to the network. Attach request. The MME and HSS will authenticate and authorize the UE. So you got this messaging. And then, of course, you do have the back and forth authentication happening here. Authenticating the UE. Then S gateway and P gateway. So you've got the create session request, and the create session responses coming back. It's not totally the same green as what I have there, sorry. And then MME forwards the session details to the UE. That's the attach complete. And then final acknowledgments and bearer setup. So the subscriber acknowledges, the UE acknowledges, and the MME sends that bearer correction, that modify bearer request to the S gateway to say, okay, here now we know the tunnel endpoint ID of the eNode B. For bearers, I just wanted to break this down. So you'll hear the term bearer very often, and in fact what we just built is called the EPS bearer. That whole call flow is all to build this EPS bearer broken down into these three bearers that we talked about. S5 bearer between the S gateway P gateway, S1U bearer or S1 bearer between the eNode B and S gateway, and the radio bearer between the user and the cell tower. Now, whenever you hear the term bearer, think user plane path or connection. Very rare, if ever, will you hear the term bearer referred to or used to refer to any kind of control plane connection. A bearer is a path that's being set up, maintained, and torn down. The reason you sort of need to logically break them up like this is because, especially when you get into mobility management, depending on what the user is doing, he might not have a radio bearer. After he finishes this attach procedure, he doesn't necessarily want to keep a constant connection with a cell tower 24/7. He needs to be connected. He needs to have this S5 24/7 in order to receive calls potentially. But he doesn't want to have a constant connection with a specific cell tower and have to maintain it all the time. Similarly, you don't want to have to maintain per user tunnels for every subscriber 24/7 on this eNode B S gateway connection, just eating up state entries in your state tables. So, and this radio access bearer similarly is just a connection between the UE all the way to the S gateway. You don't want to have to keep maintaining these tunnels. So subscribers can go into different states, in particular the ECM idle state, in this context where he says, I'm not doing anything, I'm not sending any data, I'm not receiving any data, I don't need to maintain an active connection with any one cell site, because remember, I'm a mobile device, I can be traveling across the country, I don't want to tie myself to a single eNode B, so I'm just going to be idle. When you're idle, you don't have the radio bearer, and you don't have this S1 bearer, you don't have this RAB, this radio access bearer. So you can say when you're idle, you tear down the RAB. But you still have this S5 connection, because you still need to have an IP address, and the PDN gateway still needs to know about you, because let's say this is an IMS, let's say this is a VoIP network. I drew the I first. Wow, okay. I was thinking IMS. So if I drew, so let's say this is a VoIP network that you're reaching, and he's got access to the public switch telephone network. Let's say this is a voice call. So this is PSTN, public switch telephone network. So someone picks up a phone and calls you, and you've got a phone number in this VoIP network that you've established IP connection to, and that VoIP network needs to call you. Well, it's going to be based on an IP address. You're basically a VoIP phone. You need an IP address. So a SIP invite or something might come in towards the P gateway. You need to have an IP address. So what will happen is the P gateway will say, all right, S5 is still up. I'll send this SIP message or whatever it is that's going on towards S gateway. S gateway will say, well, he has no RAB, he has no radio bearer, so he'll need to set up a bearer. What will happen is S gateway will send a request to MME. MME will do a page to say, oh, I got to figure out where the subscriber is, and then dynamically you will rebuild a radio bearer and an S1 bearer as part of another mobility procedure, where the UE will then create the bearer. He'll be told, by the eNode B that, hey, the network wants to talk to you. He'll do a service request. He'll get his bearers back, and then they'll be able to talk towards that network. But if he didn't have an IP address all the time, and he didn't have this S5 bearer, that would never be able to happen. It would be like you weren't registered. If someone were to call, you'd get that error message most likely saying the mobile subscriber you're trying to reach is not available right now because he's not registered. You have to have this S5 bearer in order to receive incoming anything. I gave this example of PSTN, but it could just as easily be an IP network or some kind of a push email service or whatever else you can imagine that you could send over an IP network that's networked towards the subscriber. You need to have S5 in order to facilitate any of that. So that's it for this video. Again, the basic attach procedure is something really fundamental, and in upcoming videos we're going to not only be breaking down those protocols for each of those different messages and those different connections, and hopefully looking at them in some good Wireshark traces as well, but also building on this a bit. I've alluded to it before and even drew the PCRF and OCS there, but there are a lot of optional pieces that can influence this setup process, where some are probably going to be important to know about. For now though, thank you for watching.